So now we're going to look at question 5. I like green for this question. Okay, so what we're doing is an ANOVA analysis of 3 groups. So we're trying to figure out if there's a difference in the quality of stain remover in these 3 groups. Okay, so we have brand A. So based on a 10-point scale, the stain removing powers of these 3 groups were as follows. You guys should have this. If you don't, then you went to the wrong link. Okay, so remember, what ANOVA is trying to do is see if there's a difference in the means, okay? And it's not going to tell us exactly what differences there are, but it's going to tell us if there are differences, okay? And later on you'll do a follow-up analysis involving confidence intervals, but that's not right now. Okay, so what you're going to be doing is the first thing you want, obviously you want the means, and you're going to want the standard deviations, okay? So to find the means, all you have to do is add up these observations, each of them, and divide by 5, because they all have a sample of 5. So you'll find that y bar 1 equals 4.4, y bar 2 equals 4.2, and y bar 3 equals 6.4. Okay, so already you kind of see that maybe this one has a bigger mean. We don't know, though, and the ANOVA analysis won't tell us that which ones are different, but it'll definitely tell us if there is a difference. Okay, and now we want to find, okay, so y bar I equals the sum from I equals 1 to ni, and ni is the number of observations in group I. Okay, so this is the equation for y bar I, and you do it for all of them. Okay, and also we want to find the total mean, and that's just all the observations together divided by the total observations, which is 5. So if you add up all these, okay, alternatively you could add up all 3 of these, and you'll get the answer. So what that means is you do 6.4, 4.2, and 4.4. So that's 6, 10, 14, 14.6, 15. 15 divided by 3 is 5. So y bar, sometimes they call it dot dot, equals 5. Okay? And that'll be useful. Okay, so in order to find SSE and SSG and all that, okay, so when you're dealing with ANOVA, SSE is the sum I equals 1 to n, of ni minus 1 times si squared. Okay? Oh no, we don't have si squared. How do we find it? Well, si squared equals the sum from I equals 1 to n I of x I, yi, sorry, minus y bar squared. Okay? Oh, and then all divided by ni minus 1. Okay? So you do this for all 3 of them, and then for each si squared, you multiply by ni minus 1, add up, and you add it to each of the other si squared. So you're going to have 3 terms in this. You're going to have 5 terms in this. Okay, so I'm going to calculate one of these. I'll give you the rest of them, and you can calculate them at home. Okay, so I'll do the first one. Okay, so 1 over n minus 1, which is 4. So 5 minus 4, minus 1, sorry, times 5 minus 4.4 squared plus 3 minus 4.4 squared plus 2 minus 4.4 squared plus 7 minus 4.4 squared plus 5 minus 4.4 squared. Okay. All divided by 4. Okay, add them all up, divide by 4. And what this will turn out to be is, sorry, squared. What this will turn out to be equals, let me get my calculator, give me 1 second. Okay, what this equals, all I'm doing is just adding up each of these, and then dividing the total by 4 minus 1. So 1 point. Okay, and you're going to end up with 3.7986. Okay. Okay? And this is what you want. Okay? Yeah, 3.7986. All right. Okay, so this is SI1. And similarly, you can find SI2 and SI3 in the same fashion. So I'll just give you S1, S2, and S3. Okay, so these are your S squared values, okay? Now all we have to do is plug them into the equation. Okay, so we find that SSE equals 4 times 1.30 plus 4 times 1.69 plus 4 times 3.7986. Okay, and this comes out to be about equal to 27.2. Now your answer might be wrong, I'm sorry. Your answer might be slightly off than this. If you did all this right, your answer is going to be this to a little bit of decimal places, give or take. There's a lot of rounding involved in this. So if your answer is 27.15, 27.18, all those things, it's basically right. It's not going to affect the answer very much. This was calculated by a computer who didn't do any rounding. So don't expect your answer to be exactly that. Okay? So now we're going to do, so we found SSE. So now we're going to find SSG. Okay? Now, remember SSG, this is question 5, by the way. SSG equals NI, equals the sum, I equals 1 to G. Okay, so the number of groups is, so there's going to be three things to add up. It's Y bar I minus Y bar dot dot squared. Okay? Times NI. Okay? So each observation is multiplied. Each observation you subtract the group mean. Each mean you subtract the group mean, square it, times it by NI. So that's going to be 5 times 4.4 minus 5 plus 5 times 4.2 minus 5 squared. Both of these are squared. All of them are. 5 times 6.4 minus 5 squared. And that equals SSE, or SSG. And you're going to find that that equals about 14.8. Give or take. Okay? It almost equals, yeah. So all of these are basically 1, so it's almost 15. Okay, so SSG is 14.8. Okay. So what we want to do next is find the F table. Okay? So we have all the things we want to find the F table. Okay. Okay, now, all right, so we have a group, error, total. Now we have degrees of freedom, SS, MS, F. Okay, now, okay, so we know the groups of the group. Okay, so we know the degrees of freedom for groups is just G minus 1. We have 3 groups, so it's 3 minus 1 equals 2. We know our error is DF. DFE is N minus G, so that equals 15. 15 minus 3 is 12. And you know that SSG and SSE always equal SS total, so that's 14. Okay, and that's a way to check yourself. If those don't add up to this, then you've done something wrong. Okay, now look at back what we had. We had SSG is 14.8. SSE is 27.2. Okay, and now remember that in order to find MSE and MSG, all we have to do is divide one by the other. Okay, so this is 7.4. Oops. Oh, also, let's see. This equals 32. Since these add up to the other one. Okay, so I mean, all you have to do to find MSG is you take this divided by that, so 27.2 divided by 12, 2.66. 2.66. Am I drawing myself? I did. Okay, so we have all the necessary components defining the F statistic. All we have to do now is divide one by the other. Okay, so we divide 7.4 divided by 2.66, 2.77. Give me 1 second. Sorry. Divide one by the other. Okay, and we get 3.26 for the F statistic. All right. Okay. Sorry. This is actually 2.26. Oops. Totally throws off the answer. Okay, now we get 3.26 for the F value. Okay, so that's pretty small. Okay, so now we have to go back to our F table. This is DF1, DF2. Okay, now DF1 is of course our numerator degrees of freedom for group. So this MSG is on the top and MSE is on the bottom. So we're going to look at 2 and 1, 2, 12. Goes all the way to infinity both times. So So what's this value? This value turns out to be 3.88. Okay? And notice this 3.26 is less than 3.88. Okay? What does that mean? Okay, so if we draw it out graphically, we have 3.88. This is 0.05, and this is 3.22. Okay? So notice this area is greater. This area is greater than 0.05. Okay? So what this actually means is that since this area is 0.05, this is greater than 0.05, which means that our p-value is greater than 0.05. And what does that mean? That means we fail to reject. Okay? That means there may be a mean difference, but there isn't enough data to say there is. Okay, so we don't have any statistically significant evidence to say that. Okay, so remember we're answering this hypothesis. mu1 equals mu2 equals mu3, and then HA is at least one is different. Okay? And we found that even though group C had like a pretty big mean, it wasn't big enough to say there was a difference. Okay? So maybe we want to collect more data to see. It's a pretty small sample, but we don't reject. And that is the conclusion.
The Teaching Center, UF's Learning Resource Center.